This is Unit 8, Area and Volume, Lesson 8.4, Nets and Solids. Please make note of both the location, the date and time that you are watching this, and don't forget to get a parent, guardian, or teacher sign-off. Let's do a review problem together. Finger track and read with me. It says a trapezoid's area is 210 inches squared. It has the height of 10 inches and one of the base lengths is 12 inches. Find the length of the other base. I'd like you to draw a label list, squeeze the sponge, ask yourself what you can do. Equations, two sides with an equal sign, circle, plug, chug. Do this on your own, then check your work. You have 2 minutes. All right, let's see how you did. Shape-wise, this is a trapezoid, so you should have drawn a trapezoid, which is two parallel lines. I'm going to draw it sideways just so you can get used to seeing trapezoids sideways. That's a base, it's parallel. That's a base, it's parallel. So I'm going to write base and base. The distance between the bases at a right angle is the height. So that red segment right there would be the height. Here's your non-parallel sides. There's your trapezoid with two bases and a height. So our equation we've drawn, and this is the information we're given. We have a height of 10 inches, so write 10 inches, and a base length of 12 inches. So we'll just call this 12 inches. We want to find the other base. We don't know it, we'll call it x. Equations, two sides with an equal sign. We have area equals, that's going to be base plus base over 2 times the height. Circle, plug, chug. We were told the area, it is 210 right there. 210 equals one base, we don't know it, call it x, plus the other base, 12 over 2 times the height, which in this case is 10. There's several ways to do this. The three most common ways would be to distribute the 10 and take it from there. Or another way would be to take the 2 into the 10 and cancel that out. Or another way would be to divide both sides by 10 completely. I'm going to go ahead and do the distributive version. So we have 210 equals 10x plus 120 over 2. That's 10 times x and 10 times 12. Now, I have a fraction, so I'm going to cross multiply. And we're going to end up with 420 equals 10x plus 120. We're going to minus 120 both sides. So we have 300 equals 10x. Divide by 10. We get x equals 30. And that is our missing base. Let's move on into new information. We've been working with 1- and 2-dimensional figures for nearly 6 months now. We're now going to walk into 3D or solids. 1 dimension is just length. 1 dimension would be anything that just has length, like a segment. Think of a piece of rope. So a segment has just length. It has just 1 dimension. 2 dimensions is basically every single shape you could possibly think of over the past several months. Triangles, 2 dimensions, rectangles, squares, rhombi, hexagons, pentagons, and the like. Anything that has length and width of any kind. Length and width. That's 2 dimensions. 3 dimensions is what we call solids. These are anything basically you can put your hand on. That would be length, width, and height. Length, width, and height. So something like a can, a soda can, would have length, width, and height. Some 3-dimensional solids that we're going to be working on in this class would be prisms. In this case, that's a rectangular prism. Spheres, cones, cylinders, pyramids, and cubes. Now, in dealing with solids, we're going to work with something called nets. A net is a pattern which can be folded into a 3D solid. So think of this 3D solid. This is a old-fashioned Happy Meal from McDonald's. They're cardboard. What I want you to do is imagine this being unfolded into a flat piece of cardboard. A flat piece of cardboard. And I want you to draw this. I'm going to give you a minute to do this. Again, you're taking this shape, and I'd like you to basically unfold it in your brain. Unfold. And draw it flat into what's called a net. Let's see how you did. So imagine you first have the bottom of the box. So imagine the bottom of the box first. And then you have the sides of the box, and they are slightly angled, ever so slightly. So there's your four sides. And then you have the top part, which are rectangles. And there's two of them. Then you have these flaps on the inside that connect it, and that's foldable. That's going to be about right here. They fold inside slightly. Then the most important part, of course, are the golden arches. And those two flaps would be something like this. What we've created, this is called a net. It's an unfolding of a 3D shape. It's an unfolding of a 3D shape. Let's try this skill on some geometry shapes. So taking a look up here, I have a pyramid, and it is a square-based pyramid that has been unfolded into a flat shape. Now there's several ways you can unfold this. There's 1, 2, 3, 4 triangles. And if you were to fold that back up, you can fold it into a pyramid. And yes, this could have easily been unfolded like so as well. So one of the tricks of nets is that there are several ways to unfold these solids. Both of these are legitimate nets, if you will. So what we're going to do here is we're going to take these solids and very carefully unfold them to the best of your ability. You want to draw these to scale, and we want to carry over all the numbers. So we're going to take this one step at a time. So I'm going to start here with this bottom rectangle. And that's going to be 15 and 6. And then we have here, we're connected by the two larger, the front and back rectangles. I'll fold them out like flaps. And that is 15. That edge length here is 15. And then this edge length is 13 on either side. Now keep track as you unfold stuff. That's why I like to use colors. Wrapped around is the additional front and back flap, and notice it's bordering the 13 here, so I'm going to bring this around. It's bordering the 13, one on one side, one on the other. And the width here is 6. And then I have this top flap that's connected, and it's bordering mostly the 15, so and there's only one of them, because remember we started with the bottom being red, and this is its mirrored image at the top, the pink, and that would be the top. So our dimensions here would be 15 and 6. You want to bring all your numbers over and your dimensions over, so you have a length of width of each one of these. That is called a net. This is a rectangular prism. I'm going to pause and let you catch up drawing as well as naming that as a rectangular prism. Let's take a shot at number 2. Number 2 is a prism as well, but it is a 1, 2, 3, 4, 5. So this would be called a pentagonal prism. It's called a pentagonal prism. I'm going to start with this base here. That's the bottom, and here we even have the apothem, 8.9, and an edge length of 13. Now I'm going to use this front piece as my hinge, my unfolding part right here. I'm going to use this top, this hinge to connect to my top pentagon. We're going to unfold that this way. Again, the edge length is 13. And the same apothem, since it's a mirrored image, is 8.9. And the blue is going to be, that edge length is 13 as well. And this height, if you're really careful, you should see that it's already 7. So bring this around, that's 7. Now you need to account for what's left. The Pentagon has 5 sides, so we need to account for 1, 2, 3, 4 additional rectangles. And they're going to be the ones that connect both the red and the green. So I'm going to use them as flaps this way. There's 1, 2, 3. Whoops, I drew that as a hexagon. We're going to need to correct that. Next time we'll count our way around. It's 5. Count with me. 1, 2, 3, 4, 5. Didn't think that looked right. So there's one edge here, and now we have our 4 flaps. 1, 2, 3, and 4. That would be these 4 flaps around this way. And all of their dimensions is 7, because it's 7 feet high. And our length, again, is 13. So they're all 7 by 13. And there is now the accurate net of a pentagonal prism. Cylinders are very, very easy to draw. Cylinders simply have 2 circles. And if you imagine slicing right down the edge of this can and laying it flat, I hope you can see if you were to lay this flat, technically it would just be one long rectangle wrapped around. So if you undo at that seam, and then you have one circle on one side, another circle on another side. Doesn't really matter where the circles are position-wise. And now let's take a moment to figure out our dimensions. This was 22. That would be our diameter of our circles, which would make our radius 11 if we needed to find the area, which eventually you will. Then the height of the can, which is also the width of the rectangle, is 20. Now, here's the tricky part. The very, very tricky part. I'm going to wait until you have this drawn because I need you to exactly follow tracing with me. So catch up, have this exact diagram drawn. I'm going to change colors here. I'm going to pick up blue. Okay, sweep around the edge of the circle, like so. Now, what I want you to see here is that if I were to unfold that which I just swept around, if I were to unfold it, that would be the edging right here. I hope you can see that. I'll do the bottom again so you can see it as well. If you were to go around the bottom circle, going around that bottom circle would be the same as this length of that rectangle. Really important question. How would you find that length? How would you find that blue length? It is the what of the circle. I'm going to pause about 15 seconds and see if you can answer that question to yourself before I answer it. Okay, trace once again. That length around the circle is that same length there. That length around is the circumference of the circle. And of course, if you needed to find that length, C equals d pi. So when you're working with cylinders, that long length that wraps around the circle, you actually have to find the circumference of the circle. Now what I'd like you to do in the next 2 minutes, you are given 3 nets. I'd like you to fold those nets back in your imagination back into a solid shape. And I'd like you to draw that solid shape in 3 dimensions. I'm going to give you 2 minutes to do that. Okay, let's see how you did. Now, I don't expect your drawings to be absolutely perfect and beautiful, but there are a few rules that you need to follow when you're drawing 3D shapes. Okay, first we have this base. I'm going to draw that first and bring it down into a 3D kind of a shape. But this back edge, technically once we fold it up, we can't see it. So I'm going to create a dotted line. These come to a point. So we're coming to a point. And what we have is a triangular pyramid. Again, one of the note things is that you need to dot lines that you cannot see. That defines depth. Okay, this one, I'm going to work first with this edging. I'm going to create that as my top. And then here's my front edge. This wraps around the bottom, so because it's wrapping around the bottom, technically, you can't see those edges. So it's dotted. Then you have these two, which wrap around the back. And what we have here is a triangular prism. A triangular prism. Now this one, because it only has one base, we know it's a pyramid. And it's a hexagonal pyramid, so I'm going to draw, and then you're going to come to a singular point. So I'm going to draw that hexagon first. That's my front edge. 2. This time I'm going to count out loud so I don't make the same mistake as I did the last time. 3. This edge I'm not going to be able to see. 4. That edge I won't see. 5. And 6. It's going to come to a point, so now I start drawing my triangles. That is not a straight line. Let's try that again. Straightish line. There's 1 triangle, 2, 3, dotted because you can't see it. There's 4, 5, and then 6. Double check your diagrams. See if you at least got the fact that they were prisms and pyramids. You'll get more practice of this in class.